So on the left of a two-column proof, you wrote your statements. What was on the right? The reason. Okay. So we're going to continue that today, but now, what specific type of two-column proof did we do last time? Algebraic, right. We solved these algebra problems with a two-column proof. This time we're talking about segment relationships, so relationships between segments. Now you're going to kind of have to bear with me this chapter. It's kind of long, okay? And like I said, I think of all these sections, it's probably the one that just takes a little bit the longest to get. It's a little difficult, not too bad. But we're going to go through a lot of examples today, okay? So we'll take it slow, but you're going to kind of have to bear with me here because we're covering a lot of different things here with our examples, okay? So this 2.7, we're proving segment relationships. So what we're going to do is we're going to write proofs, okay, that involve segment addition, so adding two pieces of a segment together, okay? And then we'll write proofs that involve segment congruence when two segments are the same, okay? So again, we're still dealing with proofs here. We'll only deal with two-column proofs here, okay, but they have to do with segments or pieces of a line, okay? So this is on your postulate sheet, the postulate 2.9, okay? So you don't need to write this down necessarily because you have it on your sheet. It's called the segment addition postulate. Maybe it looks fairly difficult. What it's saying is actually very simple, okay? It says if you have three collinear points and B's in between those two, if you add two pieces of the segment together, it's equal to the whole segment, okay? So if I added here AB plus BC, okay, that's equal to the whole thing, AC, right? Fairly simple. If this was 1 and this was 2, the whole thing would be 3. Okay, segment addition postulate, you're saying if I add two chunks of a segment together, it's equal to the whole thing. Okay, that's pretty straightforward, but we use this a lot in our proofs. Okay, saying if we can add these two pieces of this line segment together, it's equal to the whole segment. Okay. So for example here, using the segment addition postulate, how long would AC be? Yeah, it'd be 23, right? Because I know that AB is 5, so the measure of AC would be 23. AB is 5, BC is 18. Just add those together to AC. That's what the segment addition postulate says. Okay. So now let's look at it and use it in a proof. Okay. Again, in all proofs, they always start the same way. What's the first thing I write in every single proof? Yeah, Grace. Yeah, what's given to me. Okay. So what's given to me in this is that PR, so from P to R, is the same as from Q to S. Okay? If this is 5, that's 5. If this is 10, that's 10. That's what's given to me. Okay? So I'm always going to write that first in my proof, what's given to me. And then I can mark it if I want. If I want to mark PR, excuse me, that's the same as QS. Okay? Those two pieces are the same. That's all I know about this line. Okay? I want to prove that PQ, this little chunk here, is equal to RS, this little chunk here. Okay? That should be my end result. That's my goal. So what I would do in every single proof is first I'd always write the given. We know that's the first step in every single proof, write what's given to you. Okay? And then use what's given to you to arrive at some next conclusion. Okay? And always keep in mind what you're trying to prove at the end. What you're trying to prove that PQ and RS are the same. So I need to somehow start dealing with these little pieces of this line. Okay? I'm trying to prove those are the same. All right, so all I know about this segment is that PR and QS are the same. What is PR? What two segments are PR made up of? What two segments? The whole segment PR is made up of what two segments? Thank you. Yeah. Yeah, PQ and QR, right? I know that PQ and QR together make up PR. Okay? And then I also know that if I look at QS, the other piece that's given to me, the two segments that make up that are QR and RS. Right? Everybody with me there? That those two pieces make up that segment. Okay? So let me go back before this step here, and we'll write this. Did I know PQ plus QR equals PR? Right? And I know that QR plus RS equals QS. Right? PQ plus QR equals PR, and QR plus RS equals QS. Now, what's the reason for having known that? Okay. Well, how do I know that to be true? That's just the segment addition postulate. I just add two pieces of a segment together. It's equal to the whole piece. Segment addition postulate. You could also write postulate, I think it's 2.9 or something like that. Okay. I know that to be true. Okay. Again, all I knew about this segment was that PR is the same as QS. So then I just looked, I also know PQ plus QR is equal to PR. Okay. Well, again, there's tons of ways to prove this, and the way I'm going to prove it up here is different than the way the book was going to prove it. I think this way is easier. Okay, but you can decide for yourself after we get through it. Well, let's look here. Okay, I know PR and QS are the same, right? These two things are the same. So what could I say about these two things? If PR and QS are the same, what's true about what they're equal to? They've also got to be the same, right? Because PR is this. So let's just substitute a step. Let's just add another step in there. I know PR and QS are the same. I could substitute in PR right here, right? Again, you don't have to prove it this way, but let's say we did. Let's say in place of here, I put in PR because I know those are equal. I substitute them, okay? Right. I just did substitution there. I knew that these two things are equal, PR and QS, so in place of QS, I just put PR. I took this and I plugged in PR. Okay. You didn't, I'll show you in a second, you don't have to do this step, but I just did to make it easier to visualize. Okay. Well, look here, PR is equal to both of these things. So that means these two things must be equal. Right? So in place of PR here, I could substitute PQ plus QR because those two things are equivalent. Right? Again, I'm just basically moving stuff around here, saying these two things are equal, so these two things are equal. Okay? So in place of this PR, I'm going to substitute PQ plus QR because it's equal to PR. So I have QR plus RS is equal to PQ plus QR. Again, I just substituted. My ultimate goal, okay, is to prove PQ, which is right here, is equal to RS. So I've almost got that goal accomplished. I just have QR on both sides. Just like, let's say QR was 5, how would I move it to the other side? Okay, so that I was just left with RS over here. I would subtract it. And I can do the same thing with pieces of a segment. Since I have QR over here, because I only want RS on one side of the equal sign, let's subtract QR from both sides. Subtract QR there, subtract QR there. That is subtraction property. And let's see what happens when I do that. Those go away. I'm left with RS equals PQ. That's what I'm trying to prove. Now I'm done. Okay. Another way to visualize it up here, again, I was dealing with these two pieces of this line segment. I knew that if I took out this QR section, all I'm left with is PQ here and RS here. And they're equal. That's what I did. Now, technically on this proof, see how they're trying to prove that PQ equals RS, and I proved RS equals PQ? Now, those are the same things, but they're on different sides of the equal sign. So what should I do if I wanted to flip it around and make it exactly what I was trying to prove? What property is that that lets me switch it around on each side of the equal sign? Remember that? Transitive, not quite transitive. I could have used transitive up here instead of substitution twice. It's symmetric. Symmetric property. Symmetric properties just says you can flip what's on each side of the equal sign. It's still true. So technically I did that at the end just because the proof says PQ equals RS. I had RS equals PQ. Now again, we know those are the same thing, okay? But I can add one more step in there. Again, this is not the only way to prove this, okay? I could have used transitive property up here. Instead of using substitution twice, I could have used transitive property, okay? Any questions on this right here? So the way they decided to prove it is they just went straight to subtraction property. They said, well, if I have PQ is equal to QS, I could subtract QR from both sides by the subtraction property, okay? And that's the segment addition postulate, okay? Now they moved it around. I like the way we did it better, okay? They moved stuff around there and then said PQ is equal to RS. But again, your steps should always be given first, and then based on the given, what else do you know? And then try and remember your goal at the end or what you're trying to prove. Okay. All right, this one looks pretty straightforward. Okay, here's a proof. I'm given line segment AB. That's all I'm given. Okay. I want to prove that AB is congruent to itself. AB. This is the reflexive property. Okay. Well, what am I going to write first? My given. Okay, I know all I'm given is a piece of line segment. I'm given nothing else. So I'm going to go ahead and write that. Okay. Based on this, I know the reflexive property says AB is congruent to itself. 5 is equal to 5. 10 is equal to 10. AB equals AB. The reflexive property tells me AB is equal to itself. Now, I'm close to what I'm trying to prove here, but I don't quite have it all. I have AB equals AB, and I want segment AB is congruent to segment AB. Okay? Whenever you want to go from equal to congruent, you can just say by the definition of congruency, because congruency also means they're equal. Okay? So this is very important. Even though equal and congruent aren't the same thing, okay? You can use them, okay? You can change it to congruent when you have an equal sign. You can say definition of congruency. I'm trying to prove now, okay, that AB is congruent to AB. Okay. Whenever you want to go from equal to congruent, you can always say by definition of congruency. Because you don't want to stop the proof here. This is close to what you're trying to prove, but you're trying to prove they're congruent. But to go from equal to congruent, you just use the definition of congruency. You just say by the definition of being congruent, they're always equal. So that one's a very short proof. Dealing with segments. Any questions here? All right, let's look at another here. Okay, a little bit longer one here. I'm given several things here. Okay, I'm going to go to this next one here. We're going to do a fill in the blank, but I'm going to walk through it. A couple things I'm given that I'm going to mark here. Here's my given again. Anytime you're given something in a figure, go ahead and mark up the figure. Because if you don't, it's going to be hard to visualize. I know that AC, this piece, is congruent to AB. So I'm going to put the little tick mark there. I also know that AB is equal to BX. Well, that right there should pretty much tell you what your next step of your proof is going to be. Because if we look here, AC is equal to AB, and AB is equal to BX. So what do I know about these two pieces? They're the same because they're both equal to the same piece. So by the transitive property, AC equals BX. Again, what I'm trying to prove here, so our ultimate goal is to prove Y is equal to BD. The other piece of your given, now they wrote their given in their third step. I would go ahead and always write it at the top, write everything in your given. You were also given this, that CY is equal to XD. Okay. Again, what I'm trying to prove is that these two yellow pieces are together. And so far, just to this point right here, I've stopped right here. I know that AC is equal to BX and that XD is equal to CY. So I know each individual part of that line segment is congruent to the other part of that line segment. Those two are the same, and those two are the same. So I'm trying to deal with AY, so I know AY is equal to AC plus CY. If I add those two chunks together, it's equal to AY. And if I add these two chunks together, BX and XD, it's equal to BD. Okay. How do I know that? What's the reason for that? That if I add these two chunks, it's equal to the big yellow piece, and if I add these two chunks, it's equal to the yellow piece. What's my reasoning for that?
Addition.
What type of addition? Yep. Yeah, that's segment addition, right? Segment addition postulate. Segment addition postulate says if you add these two chunks together, it's equal to the whole chunk. And if you add these two chunks together, it's equal to the whole chunk. Well, then I know, okay, since AC plus CY was equal to BX plus XD, these two things were equal. I proved that right here. I know if I could substitute in AY right here. Okay, so AY is equal to BD. So a little bit longer one there, but again, always mark what you're given and then look at what you're trying to prove. And I know I was going to have to deal with AY and BD at some point. So I had to say AY was equal to AC plus CY. Okay. And BD was equal to BX plus XD. Again, always write the given. Use that to figure out some other next step, and always look at what you're trying to prove. Again, that was segment addition postulate. Okay. We also have theorem 2.2, again, on your postulate sheet called segment congruence. Okay. It just says congruence, just like equal, is both reflexive, symmetric, and transitive. Okay. Meaning if you have things that are congruent, you can use those three properties just like if they were equal. The reflexive property says A is equal to A, right? Well, you also have the reflexive property congruent, that a segment is congruent to itself. The symmetric property says it doesn't matter what's on each side of the equal sign, you can flip them around. This says doesn't matter what's on each side of the congruent sign, you can flip them around. And then the transitive property, okay, there should be a little bar over this, says if the first and second thing are congruent and the second and the third thing are congruent, then the first and the third thing are congruent. Okay? So we know what these properties are, reflexive, symmetric, transitive. Okay? Now we just have them, we can also use it for when things are congruent. Before we could only do it when things are equal. So this is theorem 2.2 called segment congruence. Reflexive, symmetric, transitive also works for congruent, not just equal. Okay, here's a proof. Okay, I'm given three things. I'm given WY equals YZ. Well, I labeled them both 3. Okay, so I went ahead and labeled that. I'm given that YZ, this segment, is congruent to XZ, this segment. So I labeled those with a little tick mark. And I'm also given that XZ, okay, this segment, is congruent to WX, this segment. So I labeled it with the tick mark. I'm trying to prove, my ultimate goal here is trying to prove that WX is congruent to WY. That's what I'm trying to prove here. I'm given 3 things. I'm trying to prove WX is congruent to WY. Now we can kind of visualize this in our head, right? This is 3. Well, this 3 is 3 with the 1 tick mark, so that means this has to be 3. So that means this has to be 3. Well, then they're the same, right? We can kind of visualize that in our head that that's true, but we need to prove this. We need to give our reasons why. So what's the first thing again we write in every proof? Given. Okay. So they just wrote the first part of their given here. I would go ahead and write all 3. They'll write the rest of the given later. Okay. But they just use this part. If WY is equal to YZ, okay, then I know they're also congruent. Because remember, you can go back and forth from equal to congruent if you say definition of congruent segments. Okay? Or you can also just put definition of congruency with the symbol. Okay? I just used this first part of the given. I said, well, since they're equal, I also know they're congruent. Okay? And you can go back and forth between the two by saying definition of congruent segments. Okay? That's all I did in that first step, was I changed this to a congruent symbol, because I know at the end what I'm trying to use is the congruent symbol. Okay. The third step, okay, this was our given. Again, I would write this all up here together, okay, but they broke it down individually. Well, if you know this, okay, and let's look at what this says. It says YZ, this piece, is congruent to XZ, this piece, and XZ is congruent to WX. So the red's congruent to the blue, and the blue's congruent to the yellow, so that means the red has to be congruent to the yellow. Okay? So I know, since WY and YZ, again, YZ, this red segment, is congruent to this blue segment, and this blue segment's congruent to the yellow segment. That's what's given to me. Then I know WY, okay, this segment has to be congruent to WX by the transitive property. Okay. Because WX is right here, I know in place of XZ, in place of this segment, I could write YZ, because they're the same, and YZ is the same as WY. So I could replace this with this, which is what I did. I replaced these two pieces to get this transitive property. I replaced these two pieces to get what I'm trying to prove. I'm trying to prove WX equals WY. Now again, I have WY's congruent to WX. That's not quite what I'm trying to prove, so I should add in one more step here. It says WX is congruent to WY by the symmetric property. Because that's what I'm trying to prove there. Again, they mean the same thing, but what it told me I was trying to prove was that WX is congruent to WY. So that's the symmetric property. We're going to look at one more here. Okay. And then I'm going to give you time to look through some additional ones on your homework. So here's a proof that I've filled out. Let's walk through how we got what we did here. So I'm given that GD is congruent to BC. So I'm going to go ahead and mark those again. GD and BC are the same. Anytime you're given something, go ahead and mark it. I'm also given BC. So this one that I already marked here is congruent to FH. So let's just stop at that point. Based on these two pieces of a given, what's something that I could probably write? If GD is congruent to BC and BC is congruent to FH, what's something I'm probably going to write in this proof? Yeah, GD is congruent to FH. If it gives you a one, like thing 1 is congruent to thing 2, and thing 2 is congruent to thing 3, then these two things are going to be congruent. Okay? Probably 90% of the time, if it gives you something like that, you're going to say the first and the third thing are congruent. And again, if you mark your picture, you know that. Okay, I marked my picture and I see, well, I marked that picture. I know GD has to be the same as FH. Okay, which, look here, based on those two pieces of information, that's what they wrote next. Okay, just from those two pieces of given, they knew, well, GD has to be the same as FH, which I have marked in my picture by the transitive property. Okay, the other piece of information they give me is that FH, okay, is congruent to AE. Well, let's just stop right there. I know FH, okay, is congruent to AE, so what do I probably know about GD and AE? They're also the same by the transitive property. Okay? So again, I can't stress enough how important it is to mark your figure. So again, GD and AE are the same. What I'm trying to prove, oh, look right there, is that GD and AE are the same. Okay? And I pretty much did that. Now this, again, you looked at this picture, you looked at this given, and you said, holy cow, I don't know if I can do this. But if you just take it one step at a time and say, well, the first and the second thing are congruent, the second, third, well, I know the first and the third are congruent. And then it told me FH is congruent to AE, so I know GD and AE have to be the same. Yes?
Did you also use substitution on 3 and 4?
Because if you wrote that, that's fine. Right, if you wrote that, that's fine. Okay. And now, how did I get from this step to this step? Because again, I'm trying to prove AE is congruent to GD. Yeah, all I did there was I just flipped around what's on each side of the congruent sign, right? So that's just the symmetric property. That proof right there is done. Again, looked really complicated, had a lot of a given, had this piece here, but if you take it one step at a time based on what is given to you, you can usually arrive at the end conclusion or what you're trying to prove. So this right here would be the symmetric property. So again, don't look at it as one whole big problem. Take it piece by piece. Write what's given to you, and based on that, what do you then know? Based on that, what do you then know? Okay. So that would be a symmetric property, because all I did was I flipped around what's on each side of this congruent symbol, and I got what I'm trying to prove. Any questions there? All right. Always start with the given, and then use that given and say, all right, what are they trying to tell me based on this given now? And here I knew based on these two pieces, well, since I marked it in my figure, I knew that GD and FH had to be the same. They wanted me to use transitive property. Okay. And then again, I knew FH and AE are the same, so since I knew that, I knew the GD and AE had to be the same. Okay. All right, so again, that was symmetric property. So that's all we're going to look at from 2.7 here.